paper 2. So we're seeing that energy crops up in both papers 1 and 2. This paper is related to the radiation and how different materials absorb and emit radiation. Jane carried out the following experiment using 2 copper cylinders, identical in shape and size. There's an important point, it's identical in shape and size, each with the same sized hole drilled along its axes. She placed a thermometer in each of the holes. Each cylinder had a different surface, so automatically now your ideas, you're thinking about what's the difference in the surfaces, as shown in the diagram below. Well, let's look at the diagram. They're the same size, it said, the same shape. The left hand one has a black surface and the one on the right has a shiny polished surface. A lit Bunsen burner was placed between the cylinders, equidistant. So again, we have some control here. There's equidistant from them, and readings are taken on both thermometers at 1 minute intervals. So we have a standard shape and size. We have the same sized hole drilled along the axes. They're heated at the same distance from the flame, and the times are constant. Each one is being measured at 1 minute intervals. Therefore, we have a lot of constants in there. After a time, the 2 thermometers showed different readings. Explain fully why this happened, indicating which thermometer showed the higher temperature. Right. In this question, I would start with which thermometer showed the higher temperature and then explain why. And in this case, if we look at it, it's the thermometer that is in the cylinder with the black surface that shows the higher temperature. So, thermometer and cylinder with black surface has higher temperature. So that gets you 1 mark stating that fact. Then we must go on to explain why this is the case. So that's your first mark. Black is a better absorber of heat, or absorber of radiated heat, because it's radiation that this relates to, than a shiny surface. So you're making a direct comparison between the 2 cylinders. One is black, the other is shiny, and you're stating the fact that black is a better absorber of radiated heat than a shiny surface. So the temperature rises more. We have to link it back to what we're measuring. So what do we get the marks for? There's 4 marks here, and again 2 marks for the quality of written communication. So don't forget, unlike what I've written here, you need to be using proper punctuation, spelling and full sentences. Thermometer in the cylinder with the black surface has higher temperature. That's your first mark. The second mark is to say that black is a better absorber, and you must mention absorber or how well it absorbs heat or absorption of heat than the shiny surface. If you wish, at this point you could also mention how the shiny surface reflects heat rather than absorbs it, if you wish, so that the temperature rises more. That's the 4th mark. So you're starting with which one? You mention that black's an absorber, compare it to the shiny surface, and then link it back to the measurement you're making, which is the temperature. One thing that you must not say here is that black attracts heat. Do not mention attracts the heat. It's more to do with the absorption and reflection of the different surfaces. So black is a better absorber of radiated heat in this experiment. Now, part 2. Use the results of this experiment to explain why aluminium foil is sometimes spread over the surface of a meal cooking in an oven. Now, there are 2 different explanations that you could use here. The first one is that foil reflects the radiated heat and it allows the meal to cook by conduction, or to heat by conduction the whole way through without burning the top surface. Right, so that's one viewpoint you could take. So the foil reflects radiated heat and allows meal to heat by conduction without burning the surface. Now, the other possibility is looking at it from the other way, is that you could say if you have the shiny surface of the foil turned inwards, the heat is reflected into the meal, so it heats up more quickly. Either or is acceptable. So you could say foil reflects heat into the meal and allows it to heat more quickly. Either of these are suitable. The main point to get in there is the fact that you're looking at reflection of radiated heat. That's the main point. Whether it's preventing burning of the surface because you're reflecting the radiated heat, the excess radiated heat away, and allows the heat to conduct into the meal without burning the surface, or you wrap it round to keep the heat into the meal and it reflects the heat back into the meal. So reflection is the main point there. Next one, state the principle of conservation of energy. Again, this is one that you should know off by heart and you should be able to rhyme off word for word. Energy cannot be created or destroyed. But is transferred from one form to another. Two marks there for that. As that is simply learning, that should be a guaranteed 2 marks for you on your exam paper. The efficiency of a machine is always less than 1. Explain how this does not contradict the principle of conservation of energy. In a machine, some of the energy input is transferred to heat and sound, so it's not converted to useful output energy, which is what efficiency measures. So to explain this, some of the input energy is converted to sound and heat. Usually we hear a machine running and feel heat being radiated from it. Sound and heat. Some of the input energy is converted to sound and heat and is not useful. And efficiency, if you wish, you can go further to explain. Efficiency is the ratio of useful output energy to total input energy. Therefore, the principle of conservation of energy is not contradicted by this statement. Now,